Lecture number 16, Digital Signal Processing course, Spring 2021. In the last lecture, we were discussing about the phase response of a system, and we define a group delay. And we said that if the phase response of a system is linear, our job is very easy. Otherwise, if the group delay response of a system is constant, then again our job is very easy. And we said that all linear phase systems have a constant group delay response. So we define a group delay entity, which is the negative of the derivative of the phase response of a system, is known as a group delay. And if we plot the group delay plot and it will be a constant, then uh, it will not cause any phase distortion in our system, because phase distortion is another kind of distortion that distorts our signal. So we want a zero phase distortion in our signal, and that's only possible if our system will have a linear uh, phase response or constant group delay response. Our second topic of chapter number 5 is drawing the magnitude plot He to raise for j omega using z transform h of z. So let me further magnitude plot mean you have h e to raise for j omega. Let me insert equation. So how we can draw He to raise for j omega if we are given h of z? So we can draw it because we can exploit the relationship between Fourier transform and Z transform. We already have the idea about the relationship between Fourier and Z transform from chapter number 3. So we will exploit that relationship to find the rough magnitude spectra using Z transform or using pole zero plot. अगर हमें pole zero plot given हो या magnitude response given हो, we can draw this one easily. So let's start very basic example. Example number 1. Let's assume we have a system. We have a system with only a single zero. We have a system in which we have a single zero. So we know that a system that consists of zero can be represented by this equation. Let me write here control Z, control V. So this could be the h of z equal to 1 minus z inverse. Let me make it 0.6 inverse. So this is simple system which have only a single zero. So if I want to plot whole zero plot of this system, uh, if I simply made it like this is equal to 1 minus 0.6 or z into 1 minus over z. Z inverse would become 1 over z, and if you simplify this, you will have z minus 0.6 over z, right? So we have 1 0 at 0.6 and one pole at z is equal to 0. So we have this system. Let me draw its pole zero diagram. So if I draw its pole zero diagram, it will look like this. So let me take circle from here for better understanding. This would be like this. Make it green, no fill. Then I need to have. So if this is a unit circle, then our pole will lie at z is equal to 0. Let me now take the pen and let me draw with red color. So you have, this is pole and this is 0. So you know that you have zeros in the numerators, and you have a poles in the denominators. So you have a 0 at 0.6. So let's draw a 0 at 0.6, and we have a pole at z is equal to 0, right? So we are given this h of z because it is in z domain. Can we roughly sketch its magnitude plot? Magnitude plot means that we want a graph between h e to raise per j omega and versus omega. So let me take this here and here. So can I draw a rough sketch of the magnitude plot? Uh, so since the location of this pole is on 0 0.6, so let me write an expression that this system would have minimum value at h e to raise per j omega. Minimum, let's call it min value, and that you will achieve at omega is equal to theta, and you can achieve maximum value of this function at h e to raise per j omega. Maximum value would be at omega is equal to pi plus theta. Now question arises here, what does mean by omega and what does mean by pi theta? So you know that this is a unit circle indicated by a green circle, and your Fourier transform will be plotted on this unit circle. This is already done in chapter number 3. So we can say that this is omega is equal to 0, and this is omega is equal to 2 pi. On same point, this is omega is equal to pi by 2. This is omega is equal to pi, and this omega is equal to 3 pi by 2. All agree? ठीक है बेटा? ठीक है बेटा?
जी सर.
Okay, so now let's, what is about theta? Theta is the angle of the zero. So currently, what is the angle of this zero? Anybody would like to help me? At what angle this zero is placed? Because z is a complex domain, so a zero should have a real and imaginary part. If it is lie on the real axis, it means this imaginary part is zero, so it has only real part. So how you find the minimum value? You just need to draw a vector from origin to the location of a pole, and the length of this pole would be 0.6. That is basically the r magnitude, and angle of this one is theta. So what about the angle? Length is 0.6. We know that if it is locating at 0.6, so if we draw a vector from here to here, so it is length is 0.6. So let me call it r mod. This is equal to the r mod, and this is equal to the 1 minus r mod, 1 plus r. Right, so what is the value of r? R is the magnitude of this vector, so we just need to draw a vector from the origin to the location of a pole. We draw this vector and name it r. So its magnitude is 0.6, so its maximum minimum value would be sorry, this is 1 minus r, this would be 1 minus r. So 1 minus r is 1 minus 0.6, so its value is 0.4. So its minimum value would be 0.4, and maximum value, and this is equal at omega is equal to theta. So what is the value of theta here? So theta is 0 here. Theta equal to 0 because it is writing on the real axis. Here value of theta is 0. So what about the value of omega here on the same location? Because this is omega is equal to theta, so it means that omega is equal to 0. You have a minimum value. Min. What about maximum value? For maximum value, you will take pi plus theta. So what about pi plus theta? It means that pi plus 0. So it's a pi. So pi is basically this point. So we are getting, actually, what we are trying to do, we are trying to find the frequency plot at these 2 points. Let me write these 2 points at the purple color. So this is omega or theta is equal to 0, and this is omega is equal to pi, right? So we are getting the rough magnitude plot at omega is equal to 0 and omega is equal to pi, because theta, the value of theta is 0. Why it is 0? Because it is lying on the real axis. So now next we need to plot h e to raise power j omega. Although we are not given DTFT, but we are given just HFZ, and by looking at the HFZ we can plot h e to raise power j omega versus omega. So now we have only two point values. One is that omega is equal to 0, because this point is omega is equal to 0, and the other point is omega is equal to pi. Omega is equal to pi. So we can see the minimum and the maximum value of this function at omega is equal to 0 and omega is equal to pi. So its minimum value is 1 minus 0.4, and maximum value is 1 plus r. 1 plus r is 1 plus 0.6, and its value is 1.6. So it means that we have to have two values. One is 0.4. The other value is, let's consider 1.6 maximum value. So what is the angle of the minimum value? The angle of minimum value is 0. So what we need to see, we need to draw its rough magnitude plot like this. So it will be 0.5, and it will reach to the maximum value at this point. This is omega is equal to pi, and this is omega is equal to 0. So this point, let me take the purple color again. So this point is omega is equal to 0. This one, let me write this. This is omega is equal to 0, and this point is this one. Omega is equal to pi. So you can call that this is maximum value point, max value point, and this is the min value point. Min value, right? So you got some idea how to find the minimum and the maximum value of a Fourier transform if you are given with h of z. ठीक है बेटा? Any confusion?
No, sir.
Okay, let's further clarify this concept and take example number 2, in which we just change the value of our location of the pole. It is not now at 0.6, but let's take it on 0.8. It will further clarify our concept about this rough sketch of the magnitude response. This is the last topic that would be the part of your midterm exam. So let's simply change the location of this pole, and let's take it 0.8. So it will become 0.8. It will become z minus 0.8 over z, right? So now what about the pole zero plot of this example? Let's write it example number 2. Now if I draw its pole zero plot, it will be look like this. So we have now pole at 0.8, not on 0.6. So let me now fill, consider this, no fill, this one. Now we have everything is same except the location of the pole. Let me take the red color, same. So we have a pole now closer to the 0. It is now on 0.8, and it has one pole at this one. So now we need to draw the vector. Let's call it vector from here to here. And we know that its length is r1, which is equal to 0.8. Agree, beta? Agree?
Yes, sir.
And what about the value of theta 1? This is again 0 degree. This is 0 degree. Theta 1 is equal to 0. So we have R1 equal to 0.8 and we have theta equal to 0 degree. Now we know that we can find the minimum value h e to raised power j omega mod min value at omega is equal to theta. So what is the value of theta? This is again in our case is equal to 0. So this is equal to 0 degree. And what is the this expression? This would be 1 minus r1. And what is the value of r1? It is 0.8, so it's value 1 minus 0.8, it is equal to 0.2. So now the minimum value of this function would be 0.2. What about the maximum value? It's 1 plus r. But maximum value would be at pi plus theta, h e to raised power j omega. This would be max value, and that is omega is equal to theta, pi plus theta. Pi is 180 degree. So pi plus 0 degree is again pi. So now we have a maximum value at pi, and that is equal to 1 plus r1, and that is equal to 1 plus 0.8. तो 1 plus 0.8 कैसे आ रहा है? अब इस पॉइंट पे थोड़ा सा let me draw here. We want to find the frequencies response. Minimum value would be at this point. So assume करें पहले बंदा इस पॉइंट पे खड़ा हुआ है, and then second point would be person at this point. This is omega is equal to theta, and this point is omega is equal to pi plus theta. Got the point? So we are looking frequency response at these 2 points. So अगर आप यहाँ पे देखें तो आपके पास जो frequency response आ रहा है वो 1 minus r1 हो रहा है. मीन अगर हम लोकेशन ऑफ 0 से यहाँ पे वेक्टर ड्रॉ करें तो हमारे पास 0.2 आता है. ऐसे ही है ना बेटा, अगर हम जहाँ पे 0 एग्जिस्ट कर रहे हैं वहाँ से जिस पॉइंट पे हम फ्रीक्वेंसी फाइंड आउट कर रहे हैं उस तक वेक्टर ड्रॉ करें और उसकी लेंथ ले लें तो हमारे पास उसका मिनिमम वैल्यू आ जाएगी. और जहाँ पे लोकेशन ऑफ पोल है उससे अपोजिट पॉइंट पे हम वेक्टर ड्रॉ करें तो यहाँ पे हमारे पास मैक्सिमम वैल्यू आ जाएगी. राइट? Let me first take this way, and then I'll give you the second way to look at the minimum and maximum value. So this is equal to 1.8. So based on the same principle, we can have a rough sketch of the magnitude plot. That is, let me draw here. This would be omega versus h e to the square j omega mod, and we have 2 values. One is at omega is equal to 0, the other value at omega is equal to pi. And we have a minimum value of 0.2, so we just go at the minimum value of 0.2, and at point pi its value would be 1.8. So this is a min value. Let me use purple color because this is a min value and this point has a max value. Any confusion? Any confusion, beta?
No, sir.
No, let me give you a second way to directly find this response. Let me say example 2a, and we solve the second method. Let's call it example 2, method 1. अब हम method 2 देखते हैं, that is more easy compared to get the minimum and maximum value. How? Let's see in example 2b. We have the same system, so we'll take the same system and try to solve it in a second way. Method 2, right? How? Again, we have a same system with 0, this one, this one, this one, and then we have this one. right? So it looks like circle millimeter, and let's draw it. So what we need to draw, let me take the pen with red color and draw the location of pole, a zero. We have a zero at 0.8. Agree करते हैं बेटा सारे? We have a same system with 0 at 0.8. Now, let me write a formula to calculate its minimum and maximum value directly by looking at the location of a pole. At e to raise for j omega mod min, and that is equal to length of r1 mod. Let me draw r1. R1 is the on the same angle, that is omega is equal to theta. And हमारे केस में अगर देखें तो this is a complex number, it is on lying on the real axis, so its theta would be equal to 0 degree, and its r would be equal to 0.8, right? So its magnitude is 0.8 and angle is 0 degree, but r1 is different from r1 is different from right? So r1 और r2 आपके पास different, r आपकी exact location बता रहे हैं. अब r1 क्या चीज है? We need to draw a vector and we need to find minimum value. Minimum value would be on the same angle, so it would be this one, and r1 is the length of this vector. What is the length of this vector? If this is whole is 1 and this is 0.8, so it's from 0.8 to 1. What is the value of r1? बेटा ऊंचा बोलेंगे दोबारा से? Could you please repeat?
0.2.
It is 0.2. So you directly draw r1 at this point. So this is omega is equal to 0. हमें नजर आ रहा है कि ओमेगा 0 पे इसकी मिनिमम वैल्यू आएगी. ओमेगा is equal to theta, and this is 0 degree. So we just need to draw the vector from the location of the 0 to the point where we are interested to find the frequency. So अगर हम ओमेगा 0 पे फाइंड करें तो यहाँ से ओमेगा 0 पे हम एक वेक्टर ड्रॉ कर लेंगे और वहाँ पे हमें क्या मिल जाएगी? उसकी पर्टिकुलर फ्रीक्वेंसी. What about the maximum value? We know that this function would have maximum value at pi plus theta. Maximum. And this is pi plus theta. And what is pi plus theta point? This is point, this one. So now you are moving from omega is equal to 0 to omega is equal to pi plus theta. Now you are here. So at this point, what you need to do, you need to draw a vector from the location of a pole, the location of a 0 to the point where you are interested to find the frequency. So let me draw it with some different color. Let me take this one color. This is better differentiate. So हम यहाँ से एक vector draw करेंगे यहाँ तक, and let's call it R2 और इसकी हम length निकाल लेंगे. This is equal to R2. This is more direct way. And R2 की लेंथ क्या होगी? देखें यहाँ से 0 से लेकर यहाँ तक इसकी लेंथ 1 है और यहाँ से यहाँ तक इसकी लेंथ 0.8 है. तो टोटल इसकी लेंथ कितनी हो जाएगी? 1.8. तो यही आंसर आ रहे थे हमारे पहले भी बेटा यही आंसर आ रहे थे. मिनिमम वैल्यू 0.2 आ रही थी, मैक्सिमम वैल्यू आपके पास क्या आ रही थी? 1.8. And this was your graph pi, and this is your 0. So you are having 0 value 0.2 and maximum value is 1.8. This value is 1. ऐसे ही था बेटा?
Yes, sir.
तो अगर आपसे कहा जाता है कि इसके अलावा कोई इंटरमीडिएट पॉइंट पे इसकी वैल्यू निकालें, फॉर एग्जांपल अब आपसे सेम पॉइंट पे कहा जाता है कि इस पॉइंट पे इसकी वैल्यू निकालें. अब हम सेम सिस्टम ले लेते हैं एग्जांपल नंबर 3 में. हाउ टू फाइंड द फ्रीक्वेंसी रिस्पांस. ये तो हमने मिनिमम और मैक्सिमम वैल्यू निकाल दिया ना, दैट इज गुड. सो व्हाट अबाउट द फ्रीक्वेंसी रिस्पांस ऑफ दिस सिस्टम एट π/2. अगर आपसे कहा जाए कि इसका फ्रीक्वेंसी रिस्पांस π/2 पे निकालें, मिनिमम और मैक्सिमम तो वैल्यू इसकी यही रहेगी 0.2 एंड 1.8. what about its frequency response at pi by 4, or maybe the pi by 8, or maybe pi by 2, or 3 pi by 4? So how you will find that response? So I'm going to explain that concept in example number 3. So let's solve together. Example number 3. Let's move to next page. Example 3. Finding rough sketch of two class particular. फिर आपसे कहा जाता है कि किसी पर्टिकुलर फ्रीक्वेंसी पे इसका रिस्पांस निकालें, तो यस यू कैन फाइंड इट. मिनिमम और मैक्सिमम वैल्यू हमें पता है. मिनिमम वैल्यू इसकी ओमेगा इज इक्वल टू थीटा पे आएगी, और मैक्सिमम वैल्यू इसकी कहाँ पे आएगी? ओमेगा इज इक्वल टू पाई प्लस थीटा. आपको आर और थीटा की वैल्यू तो क्लियर है ना, बिकॉज इट्स जीरो इज लाइंग ऑन रियल एक्सिस, तो इस वजह से इसका थीटा जीरो आ रहा है. बिकॉज रियल एक्सिस पे लाई करें तो कोई एंगल नहीं है, तो यहाँ पे एंगल इसका क्या आ रहा है? 0 डिग्री. अगर ये जीरो हम यहाँ पे उठा के लेके आ जाते हैं तो पाई बाय 4 हो जाएगा इसका. फिर हमें इसको डिफरेंटली हैंडल करना पड़ेगा. एनीवे, अब हम क्या करते हैं? वी आर गिवन विद द सिस्टम. लेट्स टेक द सेम सिस्टम एंड योर control C. Let's take a same system and draw magnitude response at take omega is equal to, let's take pi by 4. अब आपको फ्रीक्वेंसी गिवन है. पहले तो आपको कुछ भी गिवन नहीं था, आपने मिनिमम और मैक्सिमम वैल्यू निकाल दिया. स्टिल दिस सिस्टम हैज मिनिमम वैल्यू एट ओमेगा इज इक्वल टू थीटा 0 डिग्री and maximum value at omega is equal to pi. But what is its value, exact value at omega is equal to pi by 4? How we can calculate this? This is our next task. So this is pi divided by 4. We know that pi divided by 4 is equal to 45 degree, right? सही है बेटा?
Yes, sir.
So its degree is 45 degree. Let's say degree in so it's better, it's 45 degree. तो अब हमने 45 डिग्री पे इसका फ्रीक्वेंसी रिस्पॉन्स है. लेट मी ड्रॉ द सर्कल अगेन एंड देन पिक्टोरियली रिप्रेजेंट द रिक्वायरमेंट फ्रॉम दिस एग्जांपल. सो लेट्स ड्रॉ अ सर्कल. It's not circle, it is exactly unit circle. So let me use this one. Let me take these arrows upward. Let's take this one and then draw the location of 0. Keep in mind our system is really simple. It's really simple. It has only 1 0 at 0.8. Right? So what we want? Let me take a purple color because we are using purple color for frequency. Now the person is looking at this frequency axis. So this is omega is equal to pi by 4. Right? So जैसे हमने पहले किया था कि जिस पॉइंट पे हमने फ्रीक्वेंसी फाइंड आउट करनी होती थी, हम वेक्टर ड्रॉ कर लेते और उसकी लेंथ ले लेते थे. वो हमें क्या कर देता था? उस पॉइंट पे रफ स्केच दे देता था उस फ्रीक्वेंसी रिस्पॉन्स. नो, इफ वी वांट h e to raise for j omega mod at omega is equal to pi by 4. How we can find it? This is equal to the length of a vector from the position of the 0 to the point where we want to find the frequency response. तो आपने क्या करना है? यहाँ से एक वेक्टर ड्रॉ करना है, ये वाला, और आपने इसकी लेंथ ले लेनी है. लेट्स कॉल दिस लेंथ एज r2 या r3. हमने r1 r2 पहले यूज किया, तो लेट्स कॉल इट r3. so you need to take the length of this vector. तो रफ बिकॉज हमने रफ स्केच लेना है, तो मुझे नजर आ रहा है अगर हम रफली में देखूं तो इट वुड बी अराउंड कितना होगा? 0.5. अगर मैं रफली देखूं यहाँ से लेकर यहाँ तक, फ्रॉम दिस पॉइंट टू दिस पॉइंट इट इज इक्वल टू 1. तो अगर मैं इस वेक्टर को कंपेयर करूं इस वेक्टर की लेंथ के साथ, तो इट इज लेस देन 1। ऐसे ही है बेटा, रफली, क्योंकि हम ड्रॉ करें, वी आर नॉट ड्राइंग इट एक्यूरेट, बट
Yes,
रफली,
sir.
so it would be around, let's say it's 0.4549. Okay, so now we got the frequency response at pi by 4, right? So let me redraw this frequency response. We know that its minimum value would be minimum and maximum value, it will remain same. It will be 0 and pi. So it has minimum value at angle 0 degree, and it is 0.2, and let's assume it is 0. This is pi by 4. So pi by 4 पे इसकी value जो होगी, that is this point, it would be 0.49, and maximum value would be at pi, and that would be equal to 1. आगे बेटा समझ बात?
Yes, sir.
So this is
Sir,
how you,
excuse me,
जी
sir.
बेटा, जी बेटा,
सर हम इसको tan थीटा की फॉर्मूला से भी तो फाइंड आउट कर सकते हैं ना?
tan theta से I don't think
0.8 into tan of 45.
0.8 into, but 0.810.5, that would not give you the exact value, because here you need to draw the vector from the location of 0 to the location of the omega. So when you change the frequency, tan would not work here. So the length of work would be the accurate estimate, better estimate, not accurate, but the better estimate.
Okay, thank you, sir.
Okay. Let's आपसे कहा जाता है कि अब हमारे सिस्टम को थोड़ा सा कॉम्प्लेक्स कर देते हैं। एग्जांपल नंबर 4 में लेट्स टेक 2 जीरो। अच्छा, इससे पहले हम उससे भी पहले हम ये काम करते हैं, हम जीरो को उठा के यूनिट सर्कल के ऊपर ले जाते हैं। लेट मेक इट जीरो रिजाइडिंग ऑन एग्जैक्टली on unit circle. So that would be your example number 4. Let's solve that example on next page. For clarity, for your example number 4 would be, what is the frequency response of a system in single zero residing on unit circle?
सर
जी बेटा।
सर ये जो ऊपर अभी हमने R3 फाइंड किया, इसको एक दफा दोबारा एक्सप्लेन कर देंगे?
ओके, नो बेटा, नो इशू। R3 हमने कहाँ से फाइंड किया? वी नीड टू ड्रॉ, लेट मी राइट इट इन अ सेंटेंस, let me insert arrow here. We need to draw, let me, we need to draw a vector from the location of, let me bold it, location of 0 to the point where we want frequency response. ठीक है, so हमारे पास लोकेशन ऑफ 0 क्या आ रही है? z इक्वल टू 0.8, ऐसे ही है बेटा।
जी सर।
एंड पॉइंट हमारे पास क्या है जहाँ पे हम फ्रीक्वेंसी रिस्पांस निकालना चाह रहे हैं? And the point where we want to find the frequency response, that is omega is equal to pi by 4. Omega is equal to, तो हमने क्या करना है कि हमने यहाँ से लोकेशन ऑफ 0 से वहाँ तक वेक्टर ड्रा करना है एंड टेक द मैग्नीट्यूड ऑफ दैट वेक्टर। हमने क्या करना है, हमने इसको मैग्नीट्यूड लिखना है, बिकॉज हमने R3 mod लिखा हुआ, and we need to take the magnitude of that vector. That will give us the rough estimate about the frequency response of that particular system at on that particular frequency. ठीक है बेटा?
ठीक हो गया सर, थैंक यू सर।
Welcome. Hope this sentence will further clarify. So now we are going to solve example number 4, because I would say that this perhaps the one of the difficult concept of chapter number 5. Oppenheim explained it from different angle in a more complex way. But hopefully by solving these examples, you can quickly understand the main objective of this article. Actually, I'll at the end of this topic, I will try to design low pass, band pass, high pass, band reject, notch filter by using the very small trick in a very easy manner, right? So that is our ultimate objective to understand this topic. So let's take example number 4, but now we take, sorry, this is 1.8, not 0.9. So we are now trying to bring 0 on unit circle. So to bring the 0 on a unit circle, our expression would be little bit different. It will be 1 minus z inverse. Agree करते हैं? 1 minus 1 z inverse लिखेंगे या 1 minus z inverse लिखेंगे? The answer would be like this: 1 by z would be 1 by z and z minus 1. Agree करते हैं बेटा? ठीक है बेटा? Anyone?
Yes, sir.
Okay, so next we draw its pole zero plot. So it's very easy. You have this one, you have 1 0 at exactly on the unit circle. Since it is 1 minus z inverse, so it's mean that there is no angle, so it's again a real 0, so it's lie on real axis, right? So let me draw the location of the 0 for this example. Now we are bringing the 0 on a unit circle, and of course it has a pole at z is equal to 0, but for ROC we are not considering poles at z is equal to 0 or z is equal to infinity, so it is not significant. So only we have a 0 at exactly 1. Now we know that what is the minimum value of this system. Let's you are asked to draw. Let me now handle things in the same example. Kindly draw magnitude corresponds at minimum value from a max value and pi by 3 pi by 4. Let me 3 pi by 4. तो अब हमें 3 पॉइंट्स पे निकालना है, मिनिमम वैल्यू निकालनी है, मैक्सिमम निकालनी है और 3 पाई बाय 4 पे निकालनी है. तो हमें नजर आ रहा है कि लेट मी ड्रॉ इट विद पर्पल कलर. सो वी हैव अ मिनिमम वैल्यू ऑन दिस सेम एंगल. अब सेम एंगल क्या है, वो हमारे पास यही पॉइंट बन जाएगा, इसी के ऊपर मिनिमम वैल्यू आएगी, ओमेगा इज इक्वल टू 0. एग्री करते हैं इस बात से? And this is omega is second one. Maximum value we would have at omega is equal to pi, and third point we have to 3 pi by 4. So this is pi by 4, and this is 3 pi by 4. So next we are looking here. So we are first at, let me draw first, we are here at second, and we are here at third. So we need 3 points, this one, and this one. So what would be the minimum value of this system? Any guess?
0.
It's 0. Excellent, beta. It's 0 because it's exactly on the same point. So what would be the minimum value? There is no vector length because it is on same point. So a vector draw ही नहीं कर सकते. Or what would be the maximum value?
2.
1.
2. No, it's 2 because you need to draw a vector from here to here. Let me draw here minimum value h2 raised to j omega min, that is omega is equal to theta equal to 0 degree, and that is 0. Its maximum value h2 is for j omega max, and that is equal to omega is equal to pi plus theta equal to pi, and that is, let's take its r1 mod. मैं r1 draw कर रहा हूँ. अब देखें गौर से कि location of 0 to the point where we are interested to find the frequency. So let me draw a vector from here to here. तो आपको पता है 1 यहाँ से या 1 यहाँ से, तो 1 + 1 मेरे पास क्या आ जाएगा 2. So its minimum value would be 0 at omega is equal to 0. Its maximum value at omega is equal to pi is 2. What about its value at pi 3 pi by 4? 3 pi by 4 पे हम ड्रॉ कर लेते हैं. Let me take a different color. हम वही कलर ले लेते हैं. अब 3 pi by 4 पे हम इसकी जो लेंथ होगी हम ये ड्रॉ करेंगे. That is R2, right? R2 mod. So this is R1 mod and this is R2 mod. So इसकी जो omega is equal to 3 pi by 2 पे वैल्यू होगी h e to the power j omega 3 pi by 4.
सर R2 का जो मैग्नीट्यूड लिया है ये हमारा रफ एस्टिमेट है ना?
ये रफ एस्टिमेट, इट्स नॉट एक्यूरेट. आप रफ इसका स्केच करेंगे आपको रफली आइडिया हो जाएगा कि इसका रिस्पांस कितना आएगा. तो आप हम अगर रफली देखें तो इट वुड बी अराउंड 1.6 or 1.7 or 1.65. Anything you take, it will be okay. It will be a rough guess. So let's take it is 1.6. So what we are getting, we are saying that at omega is equal to 3 pi by 4. This point is 3 pi by 4 omega. So let me use the purple color again. So we have this point, and these 3 frequency points. So its minimum value. That's most important thing in this example. If you bring the 0 on a unit circle, it will eat up that frequency. इसका मतलब है ये जो DC वैल्यू है इसको इसने eat up कर लिया, खा लिया. 3 pi by 4 पे इसकी वैल्यू कितनी है 1.6. So let's make it 1.6 and maximum value is 2. So this value is 1.6 and this value is 1 exactly. So this is h e to raise for j omega mod versus omega. Any confusion beta?
No sir.
No, sir.
अगर आपसे कहा जाए कि आप यही सिस्टम सेम सिस्टम गिवन और आपसे कहा जाए 3 पाई बाय 4 और पाई बाय 2 पे निकालें, तो आपने दो वेक्टर ले लेने हैं, एक पाई बाय 2 पे और एक 3 पाई बाय 4 पे. उनकी रफ आप ड्रॉ कर लेंगे लेंथ और वो ड्रॉ कर देंगे. तो दैट वुड बी योर आंसर. ठीक है बेटा?
Yes sir.
Yes, sir.
Okay, let's take example number 5. And now we take a system with 2 zeros. तो अब हम पहले नंबर ऑफ फ्रीक्वेंसीज के पॉइंट्स हमने बढ़ाए. हमने 0 पे लिया मैक्सिमम और उस पे चलें. इससे भी पहले हम एक काम करते हैं कि हम अब 2 पॉइंट्स ले लेते हैं, वहाँ से आपको फर्दर क्लैरिफाई हो जाएगा कॉन्सेप्ट. वंस यू गेट क्लैरिटी, अब ये एक किस्म का ऐसा फिल्टर है जिसको हम नॉच फिल्टर भी कह सकते हैं. नॉच फिल्टर इन अ सेंस कि ये आपकी जो डीसी वैल्यू है ओमेगा इज इक्वल टू 0 इसको ईट अप कर रहा है, इसको टोटली ब्लॉक कर रहा है. तो लेट मी राइट हियर वन मोर सेंटेंस. इट्स ब्लॉकिंग द डीसी वैल्यू. Here, okay. So now I can use my pen. So let me point out here this system blocks DC component. Right? ये डीसी कंपोनेंट को ब्लॉक कर देगा या उसको ईट अप कर लेगा. तो अब दिस कॉन्सेप्ट ऑफ ब्लॉकिंग समथिंग इज रिलेटेड टू द फिल्टर. फिल्टर में भी आप क्या कर रहे होते हैं, यू आर ब्लॉकिंग सम फ्रीक्वेंसीज एंड यू आर पासिंग सम कंटेंट. इन यू हैव सम पास बैंड, यू हैव अ स्टॉप बैंड. तो ये हमने क्या किया है, दिस सिस्टम इज ब्लॉकिंग और स्टॉपिंग द डीसी कंपोनेंट टू पास. तो अगर कोई आपका सिग्नल है जिसके अंदर डीसी वैल्यू है तो ये उसको ब्लॉक कर देगा. Right, so next take next example number 4, which is the extension of example number 5. which is simply the extension of this concept. Example, you are given with the same system and you are asked to find the frequency response at 5 by 4 and 5 by 2 and 3 pi by 4. So let's draw this. Same system, draw magnitude, response, and omega is equal to omega is equal to, let's say, pi by 4, pi by 4, comma, omega is equal to pi by 2, 2, and omega is equal to 3 pi by 4. अब आपके पास 3 पॉइंट्स हैं जहाँ पे आपने ये frequency response find out करना है. Same example, nothing is changed. Let me draw the first the pole zero plot because that is important. Based on this pole zero plot, we are going to draw the magnitude, rough magnitude plot. It's not accurate. Again, repeating, it's sort of rough idea about this system. And then we will extend our same concept to design low pass, band pass, or high pass. So let's, in this example, again we have a same system. We have only 0 at omega, exactly omega is equal to 0, theta is equal to 0. So what we, our objective, हमने मिनिमम और मैक्सिमम वैल्यू तो फाइंड आउट करनी है, तो ये पॉइंट तो आपके पास बाय डिफॉल्ट है, राइट? उसके बाद हमारे पास 3 पॉइंट्स और गिवन है. वी आर गिवन दिस वन pi by 4, this is pi by 2, and this is 3 pi by 4, right? This is pi by 4, pi by 2, this is 3 pi by 4, right? So हम अब अगर इसका मैं रफ स्केच ड्रॉ करूं, तो मुझे पहले वेक्टर ड्रॉ करने दें. इस पॉइंट से लेकर पाई बाय 4 तक वेक्टर ड्रॉ करूंगा. लेट कॉल इट, ये बिल्कुल सीधा आपने ड्रॉ करना है. लेट कॉल इट वेक्टर r1, right? So let me change the color for r2. Let me take this one. यहाँ से आप एक ड्रॉ करेंगे वेक्टर. आई एम नॉट drawing the straight one, but you have to draw the straight one. This is r2, and let's take another one. This one is r3. ये आपने पहले से 3 वेक्टर ड्रॉ कर लिए, r1, r2 and r3. Right, so what is h e to raise per j omega min? Again, minimum value जो आपके पास आ रही है, that is 0. What is h e to raise per j omega max?
2.
2. You know, it's 2. What about h e to raise per j omega pi by 4? It's simply a length of r1 mod, and let's roughly say it is 0.58 roughly, right? So let's assume it's 0.58. What about, sorry, let me go down. What about h e to raise per j omega is equal to pi by 2? या आपके पास क्या आ जाएगा? r2 and
So
that
1.
is, let's say it's 1 point, कितना बनेगा? Let's 1.25 or 1.3 roughly. इसलिए हम approximate इधर लगा देते हैं. And what about 3 pi by 4? It's around 1.7, right?
Yes, sir.
So it's roughly 3 pi by 4. Omega is equal to 3 pi by 4. It is r3 mod. It's roughly approximately 1.7. So now we have found its values, we can rough sketch its plot. So let's say x-axis omega h into exponential omega mod. We have minimum value. Let me take purple color for this specific frequencies. So we need to find the minimum value, that is 0. We have maximum value at pi. This is 0. Then we have to find the value at pi by 4. Then pi by 2. And then 3 pi by 2. 3 pi by 4. 1 pi by 2. So now what is the minimum value? It's 0. So we need to start. This is the minimum value. What is the value at pi by 4? It's roughly 0.5. 5. And what is the value at pi by 2? It's 1.25. So it's increasing till 1.25. And what is the value at 3 pi by 2? It's 1.7. Further it will be 1.7. And then it's reaching to the maximum value of 2. That is equal to 2. Right? So we have now 4 points. This one, this one, this one, this one, and this one. ठीक है बेटा?
Yes, sir.
Yes.
Okay. Let's take the pole in the complex domain. No, sorry, zero. Pole की हम next lecture में बात करेंगे. Let's take the zero on complex plane. पहले हम single zero लेते हैं. फिर आखिर में हम केस फाइंड आउट करेंगे कि हमारे पास दिस इज एग्जांपल नंबर 6. आपकी नेक्स्ट क्लास स्टार्ट हो रही है? यू हैव अ नेक्स्ट क्लास?
जी सर, अभी है क्लास.
किसकी क्लास है नेक्स्ट आपकी?
एंटरप्रेन्योरशिप की.
आपको कौन पढ़ा रहा है एंटरप्रेन्योरशिप?
सर नूर अजीज पढ़ा रहे हैं सर.
I am not familiar about that guy anyway. Let's take 1.06. Now we need to specify the angle, and for angle I just write e to raise power j pi by 4. Let's take it on pi by 4. तो जब आपके पास कॉम्प्लेक्स प्लेन में पोल आएगा तो फिर आपके पास इस तरह से वैल्यू लिखो. To reference pi by 4. Let's take this one. So this is the expression for your simple zero that is lying not on real axis but on complex plane. Let me quickly draw its pole zero diagram, and then I need to mark its location. But just a minute, I'll not take more than a minute to draw this. This one. So straight line. This one. And this one. No, R0 is not on real axis, but its location is on complex axis. Now we have both angle and magnitude. So its R is 0.6 and its theta is 5. So it's mean that 0.6 is something here. So angle आप देख लें तो आपके पास यहाँ से यहाँ तक ये बन जाएगा 0.6. ऐसा ही है. तो ये आपका 0 यहाँ पे लाइक है, बल्कि मुझे यहाँ से इसको रिमूव करने लाइन को. So its location is this. So this is basically R 0.6 e to raise power j pi by 4 p. So its minimum value now at e to raise power j omega. Anybody would help me to find the minimum value at what frequency or what angle? Minimum value would be same principle, omega is equal to theta, but now its minimum value is theta is pi by 4. So it has minimum value at pi by 4. What about its maximum value? Anyone? What about maximum value? At omega is equal to pi plus theta.
5 pi by 4.
So it's 5 pi by 4. So roughly, what will be the minimum value? You just need to draw the vector from the location of a pole to the point. अब हमारे पास frequency minimum value यहाँ पे आएगी. Let me draw it with purple. So we will get minimum value at this frequency. Omega is equal to pi by 4 because it is equal to theta, and maximum value would be at this point. This is omega is equal to 5. तो मुझे नजर आ रहा है कि minimum value would be R1. So let me draw R1. So this is vector R1, and what will be the R2? R2 अगर हम देखें तो यहाँ से लेकर यहाँ क्या होगा? This is R2. So minimum value would be R1 mod, and maximum value would be R2. The minimum value is R1 would be 0.4, and maximum value would be 1.6. ऐसे ही है बेटा.
Yes, sir.
So its magnitude response would be like this. So you have omega h equals to omega mod. Its minimum value would be at pi by 4, and maximum value would be at pi by 4. So let me draw it with red color. So minimum value is 0.4 and maximum value is 1.6. This is 1.6 and this is 0. So with this, I am concluding today's lecture. So if you have any question, you can ask. Let me stop the recording.